The median of a set of data is the middle number when the data is arranged in order. So let's say we have the numbers 1, 5, 7, 16, 32, 41, and 71. And this information is arranged in order, 1, 5, 7, 16, 32, 41, 71. It is arranged in order, so what we need to do to find the median is just cross off from the left and from the right the same amount, and then we'll get to the middle. So we would cross off a 1, cross off 71, cross off 5, cross off 41, cross off 7, cross off 32. The median of this data is 16. Let's say your data was not arranged in order. Let's say we had 7, 4, 8, 19, 9. Say we had this data. We would first have to arrange it in order from least to greatest, and then we could find the median. So 4 comes first, then 7, then 8, then 9, then 19. And now we could find the median. We're going to cross off 4, cross off 19, cross off 7, cross off 9, and the median is 8. But for both of these sets, we had an odd number of data points. Let's say we have an even number. Let's say we have 1, 4, 7, 12. They're arranged in order, so we're able to find the median, but we have an even number. If we cross off 1, we cross off 12. If we cross off 4, we cross off 7, we're left with nothing. So therefore, we just cross off until we have 2 left. We have 4 and 7. Then we average these two. So 4 plus 7 divided by 2. 4 plus 7 is 11. So 11 over 2 would be the median. We could find that as a decimal. The median is 5.5. So as you can see from this example, the median doesn't necessarily need to be a point from the data set. 5.5 was the median of a data set 1, 4, 7, 12, and 5.5 is not even in the set of data. We also have something called the first quartile and the third quartile. The first quartile is the median of the first half of the data. So let's say the first quartile of, let's go back to our example from before, 1, 5, 7, 16, 32, 41, 71. The median of the data we found was 16. The first quartile is the median of the set of data on the left-hand side, the smaller half of the data from the median. So we divide the data by the median, we divide by 16, and we find the median of the data that's on the left, so the first quartile of this data would be 5. We also have something called the third quartile. The third quartile is the median of the set of data when we divide the data by the median of all of the data. The third quartile is the median of the set of data on the right. So we cross off this, and the third quartile is 41. The interquartile range is, you might be asked to find in the Regent, is the difference between the third quartile and the first quartile. So in this case, the interquartile range is 41 minus 5, which is 36. So the interquartile range for this data is 36. The range, you might remember, is the difference between the greatest number and the smallest number. So in this case, it would be 71 minus 1, which is 70. The interquartile range is the difference between the third quartile and the first quartile. Let's say you had a whole bunch of data points. Let's say you had, let's write out a list, not in order, 5, 8, 22, 6, 19, 91, 102, 614, 3, 8, 7, 2. Let's say you had all of these data points and you didn't feel like arranging them in order to find the median and the first quartile and the third quartile. You could do it on your calculator. Press the Stat button, press Enter by Edit, and here you have a bunch of lists. We only have one list of data points here, so we're going to enter in our whole list over here. 5, 8, 22, 6, 19, 91, 102, 614, 3, 8, 7, 2. Then you're going to press the Stat button again, right arrow to Calc, and press Enter over 1 var stats, or 1 variable statistics. Your list is L1. We don't have a frequency list, we'll discuss that next, so we're just going to delete that and leave it blank. We're going to scroll down to Calculate and press Enter. The calculator now calculates for you one variable statistics, the mean, the median, the first quartile, third quartile. We're going to look at the median, the first quartile, and the third quartile in this video. The median, you can see on the screen, is 8. The first quartile, Q sub 1, is 5.5. The third quartile, Q sub 3, is 56.5. And you would have to, if you wanted to find the interquartile range, you would have to actually do that by yourself. You would have to do 56.5 minus 5.5. And you could go to a regular screen on the calculator and solve this out. Let's say we have data. We have the number 1, and we have it 7 times. We have the number 3, and we have that twice. We have the number 8. We have that 4 times. We have the number 6, and we have that 6 times. And you wanted to find the median. Either you could write out 1, 1, 1, 1, 1, 1, 1, 3, 3, 8, 8, 8, 8, and then you write out 6 times. And then you could find the median, the first quartile, third quartile, and interquartile range. Or you could go into your calculator, stat, edit, and type in 1, 1, 1, 1, 1, 1, 1, 3, 3, 8, 8, 8, 8. You could type in all this data. Or else what you could do is clear out what you have here already. And with all of your numbers in the left column, these are your numbers, 1, 3, 8, 6. Enter these into L1, the first list, 1, 3, 8, 6. And in L2, the second list, we're going to enter in the frequency. Frequency means how often the number comes up. So the frequency for 1 is 7, because it comes up 7 times. Frequency for 3 is 2, because we have 2 3s. Frequency for 8 is 4, because you have 4 8s. And the frequency for 6 is 6, because we have 6 6s. Now we're going to press stat, calc, 1 var stats, 1 variable statistics. Our list, the list of our numbers, is in L1, so that's true. Where it says frequency list, frequency list, we're going to do second, and then the 2, so we click on the L2, because our frequency list is in L2, the second list. Then we're going to scroll down to calculate, press enter. Now the calculator calculates for us. If we scroll down, see the median is 6, first quartile is 1, third quartile is 6, and we could use this to find the interquartile range, which would be 6 minus 1, the third quartile minus the first quartile, which is 5.